Technological Literacy for Seniors, a two-part video series intended to help seniors understand commonly used technologies, become aware of the risks those technologies may face, and increase their overall safety and privacy online. Defining technologies is the first video in the two-part series. This video will help increase your understanding of how the internet, the World Wide Web, and wireless connections work from a technical perspective so that you no longer have to avoid using technologies. By the end of this video, your understanding of technologies will be demystified, and you will be able to fully comprehend the technologies you use every day. We'll first begin by explaining the internet. The internet is a relatively new technology. While the younger generation likely hasn't experienced life without it, the internet has only been around since the 90s. Even though the internet is a fundamental technology that enables many of the processes we rely on, many of us don't really understand how it works. It kind of feels like magic, but it doesn't have to. The internet is a technology that you can come to understand and feel comfortable with. So, what is the internet? Your first thought may be that the internet is the World Wide Web. These are often used as synonyms. For example, you may have heard someone say, look it up on the internet. What they really mean to say is, look it up on the World Wide Web. These two things are much different than you may think, but I'll begin with explaining the internet, since it's what allows the World Wide Web to exist. The internet is a global physical network of computers, cables, and data servers. You've likely seen the cables that make up the physical network of the internet running along large roadways or railways. There are also cables laid underground and even across the ocean floor. In fact, there are cables all across the globe, and their main purpose is to connect our computers and devices to the data servers, which is where information is stored. Let's take a closer look at how the internet works. To understand how the internet allows us to send and receive information, you first have to understand what this information is made of. When you send an email using the internet, it doesn't send that email in plain text as you wrote it. Instead, it sends it as binary information. Binary information is made of bits, and bits can be described as any pair of opposites. For example, on or off, yes or no. When you send an email, it is converted to bits consisting of only ones or zeros. A massive number of bits, 8 billion to be exact, makes up a gigabyte, which you've probably heard of when downloading a document, app, or movie. Because binary information can be sent as a pair of opposites, ones or zeros, we can send this information through electricity, light, or radio waves. Consider this. If you and another person decide that flipping a light switch on means yes, flipping a light switch off means no, and flipping a light switch twice means maybe, you could communicate through just light. Sending information as bits in the form of light beams, like this, except we use very long sequences of ons and offs in order to represent complex information. To send binary information, we often send light beams through fiber optic cables because light beams can travel very fast, 186,000 miles per second, and very far, hundreds of miles without lost range. So now you know what information looks like when it's sent over the internet. Let's take a look at what it means to be connected to the internet. Connecting to the internet first begins with an internet service provider, or ISP for short. An ISP is typically also your cable provider, for example, Comcast or Verizon Fios. ISPs are the companies that own and operate the internet cable networks. In order to connect to the internet, you first need a subscription with an ISP. If you have a subscription, you've likely had them come into your house and set up your router and your modem. These are two critical pieces of hardware that help you connect to the internet. The router is responsible for receiving electrical signals from your devices, which are sent in binary format. All signals are sent using Transmission Control Protocol, or TCP for short, along with Internet Protocol, or IP for short. TCP is a procedure for sending binary information across the internet, which requires that all information is broken down into packets. IP is an addressing system for the internet, which requires that every device has a series of numbers that makes up its IP address. The TCP and IP together are like the mailing system. In order to mail a letter, it has to be an envelope, a packet, and in order for the mail system to deliver that envelope, it needs to be addressed using a specific format, an IP address. Once the router receives an electrical signal from a device, it passes that signal onto the modem through a cord. The modem is able to use Internet Protocol to determine exactly where the signal must be sent. It then passes that signal onto a small cell outside your home through another cord. This cell is directly connected to a macro cell, one of those large towers you see along roadways or railways, through a much larger cord. Once the signal reaches the macro cell, it travels through many cables and cords until it reaches the data server that holds the information you initially requested. A data server is a very powerful computer that is primarily used to store large amounts of data. Typically, hundreds of data servers are housed in large buildings called data centers. Since the signal was sent using transmission control protocol, the server will know how to interpret the signal and retrieve the requested information. The server then packages the information as packets and returns it to the proper IP address. So that's the internet, a tangible physical network of computers, cables, and data servers. Not as mystic as you may have thought. Now that you have a foundational understanding of the internet, you can learn how the internet is used to enable the World Wide Web. The World Wide Web is an internet service. An internet service is any service that is enabled and accessible through the internet. Some other commonly used examples include email, instant messaging, and video conferencing. The World Wide Web is often shortened to the web, which is actually an intuitive name for this service. The web is an interconnected system of public web pages that are accessible through the internet. Each web page is linked to one or more web pages via a hyperlink. A hyperlink is the blue underlined text that connects you to a different web page. The web is not the same thing as the internet, although they are often used as synonyms. Instead, the web is a service that's built on top of the internet. When you search something in a web browser, you are searching the web, and that is being enabled by your connection to the internet. Let's take a closer look at how the web works. To understand how the web allows us to search for web pages and websites, you first have to understand how the web is constructed. To understand this, we'll revisit the concept of a server. A web server is a computer that stores information about a website's components. For example, its text, images, and documents. A web server also includes a hypertext transfer protocol server, or HTTP server for short, which is a software program that handles requests to access the information stored by the web server. The web server is connected to the internet through cables in the same way a data server is connected to the internet. Every single web page on the web must be stored on a web server. So all of the web pages are stored on web servers. But how do we access them? Accessing the web first begins with the browser. A browser is an application program that displays the contents of the web. Some commonly used web browsers are Mozilla Firefox, Microsoft Internet Explorer, and Google Chrome. These are typically the icons you click from your desktop screen. A web browser is not to be confused with a search engine, which we'll explain in just a moment. When you open a browser on a device that is connected to the internet, the browser is able to establish a connection to a web server and visually display the contents of the search engine's home page in a browser window. This browser window allows you to open multiple web pages at a time and offers features like a back and forward button, a refresh button, a home button, and the ability to search using a search engine. A search engine is what allows you to navigate the web. Some commonly used search engines are Google, Bing, and Yahoo. A search engine works with three processes. The first process is web crawling. Web crawling is a term used to describe using a computer program to visit many web pages on the web. This computer program is also sometimes called a spider. The spider begins on a web page and collects all of the hyperlinks that are contained on that page. It then navigates to a new page via one of the hyperlinks it connected. Once on the new page, it repeats the process again. Because all of the web pages on the web are connected by hyperlinks, the spider is able to visit millions of web pages. The second process is indexing. While the spider is visiting each web page, it is collecting information that is contained on the web page, like titles, headings, and page content. This information is transformed into keywords, which are then associated to the web page in a database. For example, a web page about New York City may be stored in the database with associated keywords like the Big Apple, Times Square, and the Empire State Building. The third process is searching. There are two ways to search using a search engine. The first way is by using a Uniform Resource Locator, or URL for short. A URL is a unique address given to each web page on the web. This is in plain text and looks something like www.websitename.com. When you type in a URL, the search engine uses a process called the Domain Name System, or DNS for short, which translates the plain text address into an IP address, which was explained in the previous video. Using the IP address, the search engine is able to send a request over the internet directly to the location of the web server that stores the information for that web page. The second way to use a search engine is by using a keyword. This is where the search engine's database comes in handy. When you make a search for a keyword like the Big Apple, the search engine searches its database for all the web pages that are associated with that keyword. For each website, it sends a request to the web server and then returns its URL as a hyperlink, as well as a preview of the web page's contents. So that's it. That's the web. As you can see, it's much different than the internet, but remarkable nonetheless. Now that you know the fundamentals, you're ready to put it all together in our last video about wireless connections. Explaining every detail about how phones and laptops use wireless connections could take several videos, so we'll just focus on how these two devices use Wi-Fi, Bluetooth, and cellular connections. Wi-Fi, Bluetooth, and cellular are all examples of wireless communications technologies. Wireless communication technology is a type of data communication that is performed and delivered wirelessly. When your phone is connected to the internet using Wi-Fi, it is sending and receiving information without the use of wires. Before you can understand how phones and laptops use these wireless communication technologies, you first have to understand how we send information wirelessly. The What is the Internet video introduced how we send binary information as light beams through fiber optic wires. To send information wirelessly, we still use binary information. However, we send it in the form of radio waves. Let's take a closer look at what radio waves are. Radio waves are a particular range of wavelengths that exist on the electromagnetic spectrum. The electromagnetic spectrum consists of 7 regions of waves that all differ in their wavelength and frequency. Wavelength refers to the length of the wave, or the distance between its two peaks. Frequency refers to the number of waves that pass a point in a given amount of time. Typically, we describe waves by their frequency. Each frequency is reserved for making a different kind of connection. Low frequencies, on the left of the spectrum, are used for connections that need to send small amounts of data large distances. High frequencies, on the right of the spectrum, are used for connections that need to send large amount of data for shorter distances. Regardless of frequency, each wave exhibits a regular pattern, meaning it will repeat its wavelength and frequency as it travels. Manipulating the regular pattern of a wave is what allows us to send information using radio waves. Similar to how we can transmit binary information as ons and offs using light beams, we can transmit binary information as highs and lows using radio waves. Because waves have repeating patterns, we can send information by manipulating their frequency. Creating long sequences of highs and lows allows us to send complex binary information. One example may look like the diagram on the right. Great. Now you understand how we send information wirelessly using radio waves. Let's take a closer look at how phones and laptops can use different wireless communication technologies like Wi-Fi, Bluetooth, and cellular. We'll start with Wi-Fi. Wi-Fi is used to connect the internet without the use of wires. We already know how the wired internet works, so all we need to learn is how phones and laptops can establish a connection to the internet using Wi-Fi. Wi-Fi uses radio waves of frequency 2.4 and 5. These are higher frequencies, so they can only send information short distances. This is why your phone or laptop has to be close to your router in order to establish a connection to the internet. Your phone or laptop uses a Wi-Fi antenna to send binary information at the appropriate frequency to your router. If your device is close enough, the router receives the information and sends it off to the internet. Simple. Next is Bluetooth. Bluetooth is used to connect two devices together so that they can send and receive information. Bluetooth uses waves of frequency 2.4 and 2.483.5. Similar to Wi-Fi, these are high frequencies. So in order to use Bluetooth, you must be close to the device you want to establish a connection with. However, unlike Wi-Fi, two devices typically have to be paired with one another before they can connect. This process of pairing gives each device a security key and allows them to be trusted and freely establish connections in the future. In order to use Bluetooth, your phone or laptop must have the Bluetooth driver turned on, and the device you wish to connect with must also have their Bluetooth driver on. From there, your phone or laptop uses a Bluetooth antenna to send and receive binary information at the appropriate frequency to the device with which you are connected. Lastly is cellular connection. In order to make a cellular connection, you first need a cellular plan with a mobile network operator, or MNO for short. There are four major MNOs in the United States. These are Verizon, T-Mobile, Sprint, and AT&T. MNOs are the companies that own and operate the cellular cable network and the cellular towers. Paying for a cellular plan allows you to use their infrastructure to send and receive information. In contrast to Wi-Fi and Bluetooth, cellular connections use waves of many different frequencies because each MNO has the rights to its own frequency. For example, Verizon has the rights to make cellular connections using 1900 frequency, while T-Mobile has the rights to make cellular connections using 1700 frequency. This is similar to how different radio stations have the rights to broadcast over certain frequencies. To make a cellular connection, your phone converts your information to waves of the frequency determined by your MNO. It then uses a transmitter to send this wave to a small cell tower. Depending how far the connection is you're trying to make, the wave will travel through cables to a larger macro cell tower where it can be transmitted further until it reaches the device you want to connect to. When you want to receive information using a cellular connection, the same process is completed, except your phone uses a receiver rather than a transmitter to accept the signal waves. Well, that's it. Those are the basic technologies in a nutshell. Hopefully, they're no longer as mystic as they seemed before. In the next video, you'll learn more about how these technologies may be vulnerable, but also how you can keep yourself safe while using them. Thanks for watching.